Hey everybody, hope you guys are doing great today. Alright, let's go ahead and get started with our next major unit, which is truth tables. Okay, so far, let's go ahead and recap a little bit of what we've been talking about. We established at the beginning, right, that our main goal in logic is to determine when an inference is a good inference, right? And an inference is one of these things that we're just trying to move from some sort of reasons to some sort of conclusion. So we talked about how we precisified these, we make these precise by putting these in terms of arguments, which is just listing out in statements, here are my reasons, which we call premises, and then here's my conclusion. And this makes it so that we're just separating, right, the reasons and the evidence for our belief from the conclusion for that belief, right, or the conclusion that is that belief, right? And so this lets us try to figure out, all right, do we think that these are good reasons for that particular conclusion? And one of the main concepts we were concerned with then was this concept of validity. This idea that, hey, what we should be doing is, one of the main questions we need to ask is, if the premises were true, if I did accept the premise, would I have to accept the conclusion? Right? Is the conclusion entailed by the premises? And one of the things we talked about was that, right, so an argument is a list of statements, and so we wanted to differentiate. Statements are these things that are true and false, right? Like our statement might be that, right, like Socrates is a man or something like that, or Socrates is a human or something like that, right? It's something that's true or false. It's where it's not just Socrates alone. It's not just an object. It's a thing that's true or false. It's a statement. And arguments are lists of statements. And so we don't call arguments true or false, we call those valid versus invalid. But, and remember, the way we define validity, right, depends on those statements in an important way, and on the truth of them in an important way. So, right, we said an argument is valid when it's impossible for the conclusion to be false when the premises are true, right? So let's go ahead and so let's just go ahead and add that note right in there. So, right, just to remind ourselves of the definition, it is impossible in a valid argument for the premises to be true while the conclusion is false, right? And so the idea is that in order to understand if an argument is valid, in order to understand, do those premises actually entail for the conclusion to be true, we need to dig into a little bit more on, yeah, well, do we, like, when are these premises true and when is the conclusion true and what's the relationship between them? Okay, so let's think about this a little bit further. So we started to use, in order to dig into this validity question about, like, all right, when is it that my premises really do entail the conclusion? We built this formal language up, right? And the idea was we wanted to make things very clear when we were talking about something. So we didn't get confused between, like, oh, are you saying Paris, Texas versus Paris, France, or, right, or like, you just being ambiguous between, like, how you're talking about it in one place versus another. So, like, we would identify our statements, and we can just zoom back, right? We would just identify our statements with singular capital letters. And that way we could just say, okay, if you want to talk about the ground is wet, we're just going to say W. And, of course, this was just the example for that day, and maybe we might have borrowed that for the next couple of weeks. But, like, over the course, all right, depending on our situation, we might define W as being a particular statement and C as being a particular statement, and so on. And the idea is that with these statements, we can be very careful, and we can just know, all right, by A, we mean this. By B, we mean this. By C, we mean this, etc., etc., etc. And again, we want to think about these statements as having a truth value, right? A is either true or it's false. B is either true or it's false. Q is either true or it's false. R is either true or it's false, right? We want to think about, and that's why it was also important for us to be, that these are statements, these aren't just objects. We're not saying Socrates is true or false. We're saying Socrates is a human. The statement is true or false, right? So each of these letters are standing for statements, and each of them has a truth value. And then as we made our way through that language, right, we started making more complicated statements, right? We moved on and we started saying, like, not just it's raining, but now it's either not raining or it's cold, right? Or, hey, if the light is on, then either the door is open or it is raining, right? And, like, we started getting to more and more complicated statements. And the point is, every time we did so, we can think about what is the truth value of that more complicated statement, like that thing as a whole. So, like, here's an example, right? G, let's say, means the car's gas tank is full. Yeah, the car's tank has gas. Yeah. And B, let's say, means the car's battery has a charge. So we can say G and B, right, means just this is what we talked about last week and the past few weeks. The car's tank has gas and its battery has a charge. I should put a comma in here, right? Like that's how we translate that statement, and we can think about not only, all right, what's the truth value of G alone and what's the truth value of B alone, but we can also just think about what's the truth value of the complex statement G and B. Is it true to say the car has gas and its battery has charge, right? And so, like, and so if we have a specific car in mind, like, so we can think about my car downstairs or something like that, right? It's true that the car does have gas, and it's true that the battery's charged. And so, like, I would like to say that this complex statement as a whole is also true. So G is true, B is true, and the complex statement G and B also has its own truth value, right? And so in this case, it seems intuitively clear, at least, that it's a true statement. Now, let's think about a different situation. I have a different car downstairs, and that car does have gas in the tank, but its battery is not charged, right? So I would say, like, okay, G, the truth value of G is true, the truth value of B is false, and so what would I make of the whole complex statement? Well, I would say it's wrong to say that the car's gas tank is full and its battery has a charge, right? Like, it's wrong to assert that conjunction, that full complete statement is true. Like, that statement as a whole is false. Now, it's still true that, yeah, the car has gas. The G is still true, but B is false, and that makes the complex statement G and B as a whole together false. Okay, so far we're just working with intuition, and hopefully this has been somewhat intuitively, like, accessible. Like, okay, yeah, sure. If I'm talking about wanting both G and B to happen, then in order to say both happened, I better have made sure that both independently, individually happened. So hopefully this makes a bit of sense, but let's dig a little bit deeper. Because, like, what happens when we get to more complicated statements? Like, even more complicated than just G and B? Like, what if we're saying, I don't know, something like, it's not the case that if it's not the case that G and B, then it's not G or it's B. Right? I'll be honest, like, don't feel like you're missing something. Like, you're supposed to understand that. Like, it's hard for me to digest all of those letters and symbols at once. Like, I can do so in, like, a little bit, but, like, just to say this in English is really weird and hard and complicated. But that doesn't mean it's not still a legitimate statement. So what we want to do is we want to figure out, right, how do I figure out what this sort of thing is supposed to say? And we're not going to be going, I'm not thinking in terms of, like, translations and that sort of thing. That's important, but, like, instead, what we want to do is we want to try to figure out, when is this complicated statement going to be true? Right? Is it true when G is true but not B? Is it true when neither one of them are true? Is it true when both? Right? Like, how does the truth value of this complicated beast depend on the truth values of the smaller, right, component pieces? Right? That's what we're going to want to figure out as we're going through this. And let's remind ourselves, right, why are we doing this? Why do we want to know the truth value of these complicated statements? Like, we started off talking about inferences, but then we shifted towards doing this whole language stuff, and, like, it might start to feel like, it's not clear how is this supposed to help me think critically or however. But remember, validity is just an argument where it's impossible for the premises to be true and the conclusion false. So if we can figure out, like if this is one of our premises for an argument, for instance, and we have another premise that's similarly complicated and a conclusion that is also complicated, then what we want to do is we want to be able to see, okay, when is it that these premises are true and when is the conclusion false? And is there any case where we can get away with true premises and a false conclusion? Because that would be bad news for that argument. So we're still doing a lot of legwork to build up to this point that you might think of as like really capturing that problem. But hopefully you can see how, right, like the seeds of how we're going to connect this over. What we're going to try to do is we're going to try to determine, just like we were looking at for this argument, right? When we saw like, oh look, this argument is valid all the time. We're going to try to find similarly valid arguments, but ones that are much more complicated. Because as cool as modus ponens is, and as nice as it is to be able to reason as like, well, if this is true, then that's true, and this is true, therefore that's true, a lot of times our inferences get much more complicated. A lot of times what we want to do is our premises, our pieces of evidence, are much more nuanced or complex or right, weird in their own ways. And it's not going to be just as simple as just plugging it into a modus ponens. What we need to do is we need to use these truth tables. Okay, that's a lot of talking. Let's dive in finally to actually doing these truth tables then. And what do I mean by truth table? I just started saying that. So a truth table is just going to be our way of listing out all the possibilities for a particular statement. And yeah, I mean all of the possibilities. So let's take something simple like just this A and B, right? Similar to the G and B above, but maybe just take it outside of the example territory for a moment. Okay. Oh, you know what? Actually, let's. It's probably better for a lot of us to use an example, so we can keep in mind G and B from above. So right, like the car's gas tank. We'll go ahead and slide this over right here. So let's say we want to figure out, we want to build a truth table for this. So I'm going to largely just dive in and we're going to try to just get the feel as we go. Alternatively, I could start with a lot of like bloated definitions that are annoying and tiring and like only really satisfy you if you're like really into the formal side of things. But instead, what I want to do is just show you like the intuition here, right? Like what you know, what an expert is really seeing or something like that. So like, all right, let's say we want to figure out when is this complex statement true, G and B. Well, all right, let's do this. Let's try to think about all of the possible ways that the world could go. Yeah. Okay. So, and by that I mean let's just have over here on the left, I'm going to put what we're going to think of as two different columns for my two different atomic statements. Okay? And then I'm going to go ahead and you've seen I've already put this like solid line down and this other line down. And basically this is going to separate what I call, or what we call, the reference columns from the operation columns. Okay? So, okay, again, let's not get bogged down with definitions. Let's just get a little bit deeper in. Okay, so now I'm going to draw one more line right here. I'm going to make this dotted though. All right. So here's what we're going to do. What I want to see is I want to look at every possible way the world could go. And what I'm going to do is on the left, I'm going to just list out all of those possible ways. Right? So what do I mean by that? Well, G could be true. Right? It could be a true statement, G. It could be true that my car really does have gas in the tank. And similarly, B could be true. Right? Like it could be true that my car's battery has charge. And so what we want to do is we want to think about this right here as world number one. Or I'll even say possible world number one. Okay, this row here, this is the world where the car has gas and the battery has a charge, where both of these statements are true. That's what we mean by T here, right? We're just saying it's true that the car has gas, and it's true that the battery has a charge. Okay. Now, before we move on to looking at our complex statement, again, I want to look at every possible way the world could go. So, we could also see that, well, the car could have gas, but, right, and I'm going to call this possible world number 2 here. The car could have gas, but this could happen while the tank is empty. Or, excuse me, sorry. The car could have gas, and this could happen while the battery does not have charge, right? While it's false to say the battery has a charge, right? So in possible world number 2, that's the situation where, yeah, we have gas, but no, we don't have battery charged. Okay, and now spoiler, we're going to have 2 more possible worlds. And so think to yourself, maybe before I fill them in, what do you think these possible worlds are going to be? Right? So we have the situation where the car has gas and where the tank or the battery does have a charge, and the situation where the car has gas and the battery doesn't have a charge. But we haven't thought about, well, what if the car doesn't actually have gas? So we can think about those situations. Right? What about the situation where the car doesn't have gas, but it does have a charged battery? Or the situation where it doesn't have either? Right? So the thing to notice here is that we have all 4 combinations in these 4 possible worlds. There's 4 possible ways that the world could go, right? If you want to think about like branching timelines and that whole thing, like the idea is, right, there's 4 timelines. There's 4 timelines, right? And these are how they're different. Now, the more details we want to include, the more complicated this gets and the more timelines we're going to have to consider, right? If we also want to consider, well, what about the possibility that the car, this other part of the car doesn't start or something like that, or this happens or that happens, right? This is going to make this more and more complicated. But right now, when we're thinking about just these 2 statements, then we can think about the world as being divided into 4 possible ways it could go. There's the scenario where both of those are true. There's the scenario where both of those are false. There's the scenario where one of them's true and the other one's false, and where the first one is false but the other one's true. Right? So this is giving me just every single way of thinking about the combinations of these particular 2 statements. And now what I want to do is I want to turn back over here and I want to say, okay, well, so in each of these possible worlds, what do we make of this complicated statement? And we already talked about how, well, okay, if I do have gas in the tank and I have charge in the battery, then it's true. It's accurate to tell me that, yes, you have gas in the tank and charge in the battery. That conjunction statement is true, right? Now, what if I only have gas in the tank? Or would you be accurate in telling me, hey, you have gas in your tank and charge in your battery? No. If I get in the car and I try to start it, then it's not going to start, and I'm going to be annoyed that you told me that it has both when it doesn't have both, right? So if it doesn't have both gas in the tank and charge in the battery, I'm not going to say, hey, it's got both, right? The truth value of the conjunction is false. That's not to say that both little conjuncts are false, right? It's true that there's gas in the tank, but it's just false that there's charge in the battery. And in order for this complex statement as a whole to be the large statement to be true, you need both sides. So for the same reason, down here in World 3, where I don't have any gas in the tank, but I do have charge in the battery, it's still false to say that, hey, you've got both, right? Unless I really do have both, it's not correct to say I have both, even if I have one, right? So it's when I have charge in the battery but no gas, it's still false to say that I have both charge and gas. Okay, and then finally, if I have neither one, then again it's false, right? If if you're telling me you're going to give me a puppy and a kitten for Christmas, and I get neither one of those things, right? It's not true to tell me I should have gotten or that I got both, right? Like that was a false promise, right? If you tell me that there's gas in the battery or gas in the tank and charge in the battery, but there's neither one of those things, then it's false to say that there's both of those things. So, looking back on this, right, the idea is the only time a conjunction is ever true is when both sides are true. And that should make intuitive sense, right? Like that's the whole point of when you say an and statement, right? When you tell someone like, "Hey, I work at Taco Bell and Chick-fil-A," you're saying, "Yes, I work at Taco Bell and yes, I work at Chick-fil-A," right? And if you didn't work at one of those things, then saying the conjunction is wrong, right? Like it's false. So that's all that a conjunction is, right? Like there shouldn't I might be beating a dead horse here, right? This might be plenty obvious at this point, but sometimes it's not. Sometimes it's hard to like get this, and like sometimes people feel weird about calling something false even when some of its parts are true. But the point of the conjunction is it's a claim about saying everything, every little part is true. So it's wrong just in case any little part is true. Okay, so as for this reference column and operations column, the idea is as we go, what we're going to do is we're going to continuously get more and more complicated statements over here on this right side, right? So right now we were trying to figure out when is it that G and B is true. But what if I want to take this? Right? What if I want to figure out when is that statement true? Well, it still is just a complicated statement based on G and B, right? So like whether or not this thing, whatever it says in English, however we're supposed to digest that, whatever it is, the truth value is going to be based on these things, right? Like so its truth value in possible world 1 is going to be based on the fact that G is true and B is true, right? Because it's just a statement about G and B. So as we go through here, the idea is we're going to be thinking about this left side as our reference, where we're just going to start off with just laying out, okay, what are all the possible values of G and B? That's like phase 1 of doing a truth table, is putting your two, or however many atomic statements you have on the left side, and then listing out just all of the combinations, right? So if it was just B alone, right, then I could delete G, and then look, I actually have too much. I could just narrow it down to just 2 possible worlds, right? Just where B is true and B is true and B is false. As soon as I add back in, as soon as I add in another letter, well, now I got a lot of complication. Now I have, well, the situation where B is true and G is true, but also B could be true and G could be false, right? So I have to think about all 4 of those. And then, right, if I were to go further, if I had another letter in here, right, let's say I also had something like A, well, then I would have to think about all of these 4 cases while A is true, and then think about all 4 of those same cases while A is false, right? So I would be effectively doubling the number of possible worlds. So every time we add a new atomic statement, we're going to have more and more reference columns which double the number of possible worlds. And don't worry, I will, like, generally speaking, there's like an old like line that's like a good long truth table is good for the soul, but like I'll try to avoid giving you things that are too long because that just gets tedious. But sometimes it's good to do at least one just to get the taste for it. But anyway, the point of all this is just to say we're going to put our reference columns on the left side, which are just going to capture all of, right, all of the possible ways in which the atomic statements might might occur. And then what we're going to do is on the right side, we call these operation columns because this is where we apply, we take the reference columns, and then based on the connectives, we determine, okay, what is the truth value of these more complicated statements, right? What are the truth values of you might think of it as the truth values of the operators, right? If these are the truth values of the individual letters, then every time we combine to make a more complicated statement like G and B, we can think about that new truth value as, right, it should be attached in some way to the operator, which creates this more complicated statement. Okay, so as we go, right, like that's the general gist of the idea, right? We're going to have our reference columns on the left. We're going to try to fill them in on the right. We're going to build up to getting to something this complicated. We're not going to do this right away, so don't worry about that. Let me go ahead and just fix this. Okay, so in order to do this then, this should be false. In order to do this then, what we need to do is we want to certainly not just go off of like intuition or something like that, right? So to start here, we essentially were just intuition pumping, right? We were just like, what do we think is the most likely way of digesting this? But remember, the point of logic isn't just to like fall back on your gut feeling or something like that. Instead, we want to get a nice, clean, clear, and just crystal way of going about this that anybody can say, oh, yep, you know what? I don't have to just trust your gut. I can see exactly what and why you're doing what you're doing, or why you're saying what you're saying. So let's think about this for a second. Okay, so let's look at this quick definition of a truth table just to make what we were just talking about more precise. So a truth table is just a table, right? That's what we're looking at, where each row is a combination of the truth values of the atomic sentences, and each column is for a connective or an operator, right? So each row is going to pick out some combination of our atomic statements, right? So we're going to, in world one, we're looking at, okay, this is what happens when G and B are both true, all right? If we want to think about, all right, what happens but if G is false and B is true, then we look to world three, right? So world three is the row of that particular combination of our atomic statements. And then each column here, each of our operations columns, right, these are picking out the truth value of a particular statement, right? Here, right, it's the statement G and B. As we get more complicated statements, right, they'll pick up the truth values of either the components of those complicated statements, or the last will be the truth value of the statement as a whole. But yeah, we'll get into this as we go. So the thing to remember about is each row is a different world, a different way things could be turning out. And each column is just us evaluating the particular connectives within each world. All right. So again, so this will happen. I don't know why that keeps happening. But this will be more clear the more like exercises we actually do with it. So let's look at these three truth tables next. So these truth tables we're going to need to get really familiar with. These are what we think of as our canonical truth tables, or our foundational truth tables, right? The idea is each of these three, and we're going to look at two more for our other two connectives, tell us how should we be thinking about how the connectives will change, or how the truth value of the connectives will depend on their components, right? So like, let's look at just this negation here first, right? Suppose I have this statement phi, and I want to know, all right, when is it that not phi is going to be true? So, well, I look in world one, and in world one, right, if I'm thinking about phi is true, then to say not phi is false, right? So if phi is something like Santa Claus exists, and in world one it's true that Santa Claus exists, then it would be false to say Santa doesn't exist, right? But if in world two, right, the second row, Santa really doesn't exist, is false, that phi, then it would be true to say it's not the case that Santa exists, right? So the idea is a negation is always just going to, like, any negated statement is just going to have the opposite truth value of the thing that it's negating, right? If you started with a true statement and you tried to say, hey, it's not the case that that thing, well, then what you said is false, right? If the thing was originally actually true. But if you started with something that was false, like, hey, unicorns exist, well, then it's true to say, hey, it's not the case that unicorns exist. So as we do these tables, all we're going to, well, like, and when we see a negation, what we're going to think is, all right, let's take whatever the truth value that it's applying to, and we're just going to flip it. We're just going to swap that. We're just going to take things that are true and call them false, and things that are false, and we're going to call them true, right? Because if the statement started off as true, then negating it is something that's false. And if it started off as false, then it's correct to negate it. Okay. So, hopefully at this stage, this is still making like some level of intuitive sense, but like, don't be afraid if still it's not, you're a little bit lost, because until we just keep doing more exercises, it's difficult to really see like what, what I mean by what we're doing with these operators and that sort of thing. Okay. We already looked at this and one on the right. Notice, right? So if I have this statement phi and theta, right? Well, okay, the only time phi and theta is going to be true is when I have both phi and I have theta. If I just have one and not the other, then it's false to claim that I have both. If I have not the one but I do have the other, it's still false to claim that I have both. And if I have neither one, then it's false to say that we have both, right? So that's and, right? So and that's just what we were looking at over here. Just this idea that the only time a conjunction is ever true is when both of the sides are true, right? If we're living in this third possible world where we don't have phi but we do have theta, it's wrong to say that both phi and theta happened. Now compare that with the or here in the middle, right? This phi or theta. What we're trying to say is, all right, we're looking at the same four possible worlds that we did for and, right? When they're both true, one's true, the other's false. One's false, the other's true. They're both false. But notice here, the only time it's false is when they're both false. Because, I mean, that's what we mean by or, right? If you tell me I'm either getting a dog or a cat for Christmas, then, and I get a dog, right, like possible world number 2, then I'm happy. And I say, yes, you kept your promise. I got a dog. But even if I didn't get a cat. But if I didn't get a dog and I got a cat, I'm still going to say, yeah, no, that's true. You still kept your promise, right? I still got either a dog or a cat. And if you gave me both a dog or a cat, I am still going to say, yep, you were right. It's true that I got at least one of those things, and I did get at least one of those things, and I'm happy because I got both. The only time that this is false is if you didn't get either one, right? If you didn't get either a dog or a cat, then you would say, no, it was not correct to say you got either a dog or a cat, right? So one thing to pick out here is also that by this, we're talking about an inclusive or here. And by that, we mean if we got both, we're still happy. So there's another completely legitimate way or a completely legitimate type of or statement, right? Like if I say you can either have the sandwich or you can have the steak, right? Like, I'm a chef about to cook you a meal or something like that, right? You might be implying that you're not allowed to have both.
and we can express that sort of thing in our language just fine. We'll just say like you can have A or B and not A and B. But like the point is when we're talking here, we're trying to say no, you can have either one and you could have both, right? So it's more like if I said um, you can get into the party if you either know somebody or you pay somebody money. If you know somebody and you pay them money, then sure, you can still get into the party, right? And that's the sort of or we're talking about. So we mean an inclusive or here. So the only time we ever think an or statement is false is when both of those things are false. But if one of those is true, that's what we mean by or. Okay? All right. Again, a lot of this will sink in much more as we get to the exercises just below. All right. So, real quick, also remember what a main operator is. So we finished off last main unit and last week with talking about main operators. These are the operators when we're doing a big complicated statement that appear last. And the idea is that, or when I say appear last, I mean, right, like if we were constructing these statements, they would be the last piece of the construction. The idea is that they have everything else in their scope, right? So if we look up here, right, on this statement, the and is the main operator, right? Because it sees the entire left side and the entire right side. And the idea is, as we're doing this, the truth value of the entire statement, we're going to get that by finding out what is the truth value of that main operator. We're going to start off, basically, we're going to go inside out for all of these. We're going to start off with knowing the truth value of the little things, right? Because that's just given to us by each little world, right? In this world, R is true. So we're going to keep... And then we're going to say, okay, based on R and C, what about this thing? Right? What about this thing? And then we're going to finally build up to the main operator. And it's that last main operator value that's going to tell us the value of the sentence as a whole. But too much talking. Let's actually get to some actual examples. So let's look at this. So here I have I have a statement again, just G and B. So I have these two reference columns on the left. And I'm already giving you a hint. Hey, look at this. We have 4 possible worlds to fill out. So G, I know, well, so maybe let's start with B. I'm going to explain this a few times. You might feel like this gets redundant, but sometimes this is really helpful for people just to absorb what's going on here. Okay, so the idea is, right, B could either be true or it could be false. And both of those things could happen while G is true, but both of those things could also happen while G is false. So I have my 4 possible ways the world could go. Now what I want to do is I want to think about, all right, what is the value of this statement in each of these possible worlds? And here, I'm betting that some of you can just look at this, maybe, and see like, oh, I think it's this answer, that the whole statement is false here, and the whole statement is true there. I want to urge you very strongly to really resist trying to skip those steps. Not because you can't do it to some reasonable degree early on, but because if that's all you're doing on these simpler examples, then when we do get to the complicated ones, you will not have a good time. And I'm not saying that in like any sort of like, you're not clever enough. That's not what any of this is about. This is just how it's done, and the proper, not just like the proper following rules, but like the way to do it accurately. Remember, the whole point of what we're doing here is to make it so it's not a trust me bro thing. Not a, oh, I went with my gut and I know it's true. I don't trust it. I don't trust, like, we're not trusting guts here, right? Like, you need to be able to slow down. And can you slowly explain to someone who just doesn't believe you, maybe, why? No, this is absolutely the case. And we're not going to be doing that just like willy-nilly, hand-wavy every time. Like, don't you just see it, or can't you just think about it? Aren't you smart enough? We're going to make sure we can actually slow it down so that way you don't just feel like you know what you're doing. you can actually rigorously do it like a mathematician or a logician or a philosopher would do it. Okay, so in this case, right, I need to slow down and I need to think, all right, so what's my main operator here? Right? I have this statement, it's not the case that G or B. But we need to be careful. Am I saying it's not the case that either G or B is true? Or am I saying either it's not the case that G or B is true? Right? This goes back to what we were talking about all last week and for the past few weeks, really. And hopefully, if you're feeling confident and comfortable with what we were talking about, right, this negation is only applying to this G. So we simply cannot determine the truth value of the disjunction until we figure out, yeah, okay, well, is the left side true? The left side is this big, complicated, not G thing. I need to figure out if that's true first. Okay, so let's just start in our first world here, where both G and B are true. So in the first world, I'm going to have to just start here. In the first world, G is true. So what do you think not G is? Well, it would have to be false, right? So, right, this column here corresponds to the negation there. And then this column on the right corresponds to the or here. So the idea is, okay, so we have this or. On the left side, the not G is false. On the right side, the B is true. Right? In the first world, the left side of this or is false. That's what this is. And the right side, this B, is true. Okay. So before, like, if I didn't have this, then I would just have a single column, right? And I would just say, oh, okay, the left side is G. I just have to look right there. Let me maybe bold this stuff to make it clear what I'm looking at. And then I could just say, oh, well, clearly true on the left, true on the right. That would be a true or statement, right? Because that's all that or is asking for. But because this statement has this extra negation, I first need to take care of that. I first need to figure out, okay, so what's the value of the left side? It's not just G, it's the negation of G. So the truth value is the opposite of whatever G's truth value is. And now I can say, okay, the or here, it's going to look at this false and this true, and we're going to, let me just go ahead and right? And we're going to say, okay, if the or has a true on the right-hand side, but a false on the left-hand side, right? That's like this situation. And in that situation, we say, okay, that the statement as a whole is true. Right? So that's all we're going to have to put here. So let me actually just take this. Okay. So, like, the idea, just because I know this can be very confusing at first, it's as if on the left side, right, we see, so it's as if we see on the left we have F, on the right we have T, and so we look at this truth table diagram, right, like this is our recipe booklet for how to determine when is an or true, or when is a conjunction true, or when is a negation true. The idea is you say, okay, I have an F on my left side, that's the not G. I have a true on my right side, that's the B, right? And then because of that, F on my left, true on my right, that tells me that the or statement should be true. So that's why we put that right there. Okay. So that's all that's happening here. So the idea is each of these columns here are just corresponding to one of these connectives. So let's just go ahead and move along. The more we do this, the more this will start to sink in, if it's not already. So again, the idea is, all right, so I need to evaluate, all right, what is not G in this second possible world? Well, in the second possible world, G is still true. You still have gas in your tank. So it's false to say, right? It's false to say that you don't have gas in your tank. And now I can say, okay, now what about the statement either not G or B? Well, so on the left-hand side, I have this false. But on the right-hand side, B is also false, right? So either you don't have gas in your tank, that's false, or your battery is charged, but that's also false. So we have a false on the left, a false on the right, right? I'll just put that there just to try to make that clear. A false on the left, a false on the right. And so when we look at our truth table, it says, oh, if you have a false on the left, a false on the right, well then the disjunction should also be false. Okay. And so then let's move on to the next world. So in the next world, it's actually false that the gas is full. So if it's false that the gas is full, right, then the negation says, okay, it's true that the gas tank is not full, right? And same in the last one. And then I can just think, okay, so I have a true on the left-hand side of my OR, a true on the right-hand side of my OR, a true on the left and a true on the right means I should be putting a true down here. And then again, I have a true on the left-hand side, a false on the right-hand side, and so then I should be saying, right, a true on the left plus a false on the right means that the disjunction itself is true. Okay, so all that we're doing is we're just trying to say, in each of these worlds, right, how do we understand the value of a particular connective? And what we need to do is we need to start with not the main connective, but the connectives that are most closely attached, right, just to the atomic statements. All right, let's keep going. Okay, so here, we actually have to double the amount of worlds we're dealing with here, right? Let's look at this. We have G, B, and also S. So let's think about it. We have the world where T is, so we can think about the situation where B is true, but also where B is false. And both of those can happen where G is true, but both of those can also happen where B is false. So let's go ahead and add these down, right? So we have those same four combinations we've been talking about. But then notice, right, we could think about all four of those combinations happening when S is true. And we can think about all four of them happening when S is false. So again, I'm just going to go ahead, put that there, and put that there, right? So, I mean, let's review these to make sure we're sane and we see what's going on. So the idea is we have the world where all of them are true, ST and G, or SG and B. We have the world where all of them are false. We have the world where S and G are true, where G and B are true, where S and B are true, where just S is true, just B is true, just G is true, just B is true, right? So we have literally every combination of all three of these atomic statements, right? And so let me rename these. This is possible world 5, possible world 6, possible world 7, possible world 8. So right, as we go then, right, we're going to have a number of possible worlds. The number of possible worlds equals 2 raised to the n, right? Where n is the number of atomic statements. So this is why when we just have B alone, we just have T or F, right? It's just 2 to 1, 2 to the 1. When we have B and G, we have 4. Then we go to 8, then 16, then 32, then 64. So this is why, right, like I was saying, we try to avoid, like I'm never going to give you something with like 20 atomic statements because 2 to the 20 is a ridiculously large number. Okay. But, okay, so this gives us all the possible ways of things going. And now what we want to do is we want to think about, all right, how does this work? Like, in each possible world, how does this affect the truth value of this more complicated statement? All right. So let's maybe even start, like, suppose we tried to start in the wrong place. Suppose you thought, oh, let me do the and first. Well, again, remember how this works. The idea is, in order to know if this and here is true, if the main statement as a whole is true, well, I need to know, is its right side true and also its whole left side? Right? So before I know whether or not that and is true, I need to determine what is the truth value of this entire left-hand side. I would just be guessing, right? I don't want to just try to like do that in my head really quick before I do the and. Instead, let's just lay it out. So then I move inside the parentheses, right? And I ask, okay, so in order to know the value of this or, I need to know the value of B as well as the value of not G. And so I need to first, before anything else, I need to figure out, okay, what's the value of not G? And so in world 1, so we can do this world by world again. So in world 1, right, since G is true in world 1, then that means not G is false, right? And so, yeah, let's go ahead and just finish at least this first row. So that's that. Not G is false in world 1. So what about the statement G or B? Or not G or B? Right? Well, okay, it's an or statement. So it's true just in case either its left-hand side or its right-hand side are true. Its left-hand side is this not G, which is right here, right? And that is false. Its right-hand side is B, right? And that's true. So we're going to go ahead and in the column here for the or, we're going to go ahead and put a true, because its right-hand side is actually true. And then what we're going to do is we're going to say, okay, so now I actually know the truth value of this whole sub-statement here, right? This whole thing here is true. And so I can say, okay, I have this conjunction. It has a true on the left-hand side, right? And it has a true on the right-hand side, because in world 1, S is true. So that means I can say, okay, that statement is also true. So I think it might actually be helpful if we try to go down maybe by columns a little bit. So let's think about, now that we see like what order we have to do this statement in, let's think just, all right, every time then we have to do not G first. And then once we have not G, we know whether or not G or B is true. And then once we have not G or B, we can decide whether or not the conjunction as a whole is true. So let's maybe do it in just that order throughout, just to maybe drive home some of these points. So in world 1, G is true, so not G is false. World 2, G is true, so not G is false. World 3, G is false, so not G is true. World 4, G is false, so not G is true. 5, true means not G is false. Right? Notice that I'm just flipping it every time. Right? So since G is true, true, false, false, true, true, false, false, not G is false, false, true, true, false, false, true, true, right? Because it's just the opposite, has the opposite value. And so now I can think, okay, so in each of these worlds, what's the value of this component not G or B? Right? Well, I know that not G has these values all the way down, and B has these values all the way down. Right? So in the first world, right, we already saw that, okay, so you had a false on the left, but you did have a true B, so we were good. How about in the second world? We again have a false on the left, right? This not G or B. But now, look, B is also false. The right-hand side of this disjunction is also false. That means the disjunction as a whole is false. In the next world, we have a true on the left. Not G is true, so the disjunction is true. And we're we can also see that the B is also true. We only needed one, but we got both. In the next world, again, not G is true, B is false, but one side was good enough. Right? In the next world, not G is false, but B is true, so that's okay. Like, right? Because again, all I'm doing in my head is bouncing back to this idea that the only time I'm ever going to say that the disjunction is false is when both the left-hand, right-hand side of it are false, right? When both its phi and its theta are false. But short of that, I'm going to say, yeah, no, those things are true. Okay, so again, so in the next one, I have not G is false, but also B is false. So that's the one time I'm going to say the disjunction's false. Not G is true, and B is true, so that's good enough for a truth. And not G is true, so that's again good enough for a truth, even if B is false. And then finally, I can do my conjunction, right? I can just ask, okay, I need a true on the left-hand side, which is this column right here. And I need a true on the right-hand side, which is this column right here. Right? We already saw that in the first world, okay, we got a true because we had a true, not G or B, and a true S. And then, right, so in the next world, we have a false left-hand side. Then we have a true left and right, a true left and right, a false right-hand side, a false on both sides, a false on the right-hand side, and a false on the right-hand side. Okay, now let me go ahead and unbold these. And so this column, right, this is the truth value then of the main operator, right? If you want to know when is it that both S and not G or B is true, well, it's true when S, G, and B are true. It's not going to be true when S and G are true without B, right? And I could keep going throughout all of these, but like that wouldn't sound terribly interesting, I wouldn't imagine, right? But the point is, this is showing us the whole sentence, the sentence as a whole, right? Its truth value depends on just those little pieces on the left-hand side. And what we were doing was, like, each one of these columns, we were just, like, cranking through, like, okay, how does each one of these connectives affect that final answer? And then the final connective we did, right, tells us, okay, that is the truth value of the sentence as a whole, right? When S, G, and B are all false, then it is false to say that both S is true and either not G or B, right? That sort of thing. Now, in this case, it worked nicely by having this, like, okay, first we did this column, then this, we worked left to right. But sometimes, right, like, the statement might not be set up like that, right? So, if for instance, the parentheses to this worked like this, now my main operator would have been different, right? So now all of this would have been, so let me delete it without, all of this would have just been wrong, so we would have to change all of this, because now, right, depending on, like, when we change the structure of the statement, now, oh shoot, I can't do my or first, or like, I still have to do my not G first, but I can't do my or next. I would have to do my B and S first, right? And then I could do the disjunction last. So the main operator would change, and so would be the order in which you do these sorts of things, and then the answer as a whole would be different. And right, and that's because, and that should make sense. It's just a very different statement than what we were working on. Okay, so that's that. What we're doing is we're working with the letters on the left-hand side, right? What are the truth values in each possible world? And then based on those truth values and our instruction set, we decide, okay, these things are true and these things are false. All right, let's do a couple more examples. All right, how about if we just have one atomic statement, right? Well, then all I know is it could either be true or false. Those are all the possibilities. So I come over here and I say, all right, hey, again, I don't know the value. Before I can do the or, right, the or I need to figure out when is not G true. So I need to do that first. So not G is going to be true in the first, or false in the first world and true in the second. So now I can ask, okay, so when is the OR going to be true? Right? And let's go ahead and take this out. And well, let's think about it. In the first world, the left-hand side is false, the not G, but the right-hand side is true, so we're good. It's true. In the second world, the left-hand side, not G, is true, and the right-hand side is false. But it's still true, because the OR only needs one truth. So notice, in every possible way the world could go, our statement as a whole is true. This is what we call a tautology. That no matter what G is, regardless of if it's true or false, the statement either G or not G is true. Right? And that should make intuitive sense. If I just said either Santa exists or Santa doesn't exist, it's like, oh, well, sure, right? Like, yeah, either it does or it doesn't, right? Like, either snow is white or it's not white, right? Like, okay, cool, you're covering all your bases. You're not saying anything like substantive or like that differentiates how the world really is. Like, yeah, no, that either my name is Sean or it's not Sean, right? Like, in this case, it happens to be Sean, but it doesn't matter. It's true either way. Either my name is Bob or it's not Bob, right? So this is what we call a tautology, and a tautology is something that's always true. Compare this with what's going on over here, right? Same sort of thing. I have a true and a false G. And so I can think about, all right, well, in the first world, not G is false. G is true in the second, right? And in the second world, not G is true. And so then when I want to say, all right, what about the statement not G and G? Well, I need G to be true and not G to be true. I would need true on both sides here. But in both cases, right? In the first world, I have one true and one false. In the second world, I have one false and one true. And because this is an and, right, in order for a conjunction to be true, you need to have both statements being true. Okay, so all of this comes down to this idea that we can categorize our statements in different ways. Some statements are what we call tautologies, right? They're true in absolutely every possible world, right? These are like mathematical statements, like 1 + 1 = 2 is true in every possible world, but we won't get into math here. Possible statements are the ones we started with here, right? Maybe not G or B is true, right? It depends on which possible world we ended up in. If we're in world number 2, it's false. If we're in world number 1, it's true. Right? It's a possibility, it's not a guarantee. An impossibility is like what we just saw at the very end here. The idea that no matter what G is, this complicated statement cannot be true. G might be true, but to say G is true and it's false is always wrong. Right? To say snow is white and it's not white, right, is just a false statement. So that's what we mean by an impossibility, something that is not true in any possible world. A contradiction is a special type of impossibility of this form that I just showed you, where you're saying something is true and it's not true. And we'll talk about these more as we go, especially in the later units. But it's a specific type of impossible statement, a type of statement that is always going to be false. There are others too. Okay, so what these truth tables let us do is they let us get a good sense of, right, when is it, not just a good sense, but they let us see exactly when are statements going to be true and when are these statements going to be false. And it just is a matter of just slowly looking at, okay, what are the values of the atomic statements in each individual little world? And then how are these atomic statements being connected, right? We're going to look at the rules for the conditionals next week. But I wanted to get you started with just thinking about truth tables to begin with. Okay, as always, let me know if you have any questions, and stay safe out there.